I'm Dan Gross. I'm coming to you live from Duke's Fuqua School of Business, where we host LinkedIn Live sessions every first and third Wednesday of the month at 12:30 Eastern. I'm a faculty member in the strategy department, where I'm doing research on crisis innovation management and policy and automation in the future of work. And I want to give a shout out actually to any Weekend MBA students of mine who may be watching. You all did fantastic work getting our course off the ground this past weekend, and I'm excited to see you next time. Now, today I'm going to be talking about crisis innovation policy, taking stock of the US policy response to two crises where innovation was crucial to resolution: World War II and the COVID-19 pandemic. To compare these efforts, identify key trade-offs for crisis R&D management, and evaluate the long-term impacts that crises can have on the US and global innovation systems and high-tech economy. I'll be answering your questions in a few minutes, so please feel free to drop questions into the comment box. But at this point, I would like to ask our team over here to share my screen now. Super. Thank you, John. We have just great staff in the background helping to make this production happen. So really hats off to them, John and Jennifer. So here we go. I first actually want to give an acknowledgement to my co-author, Bhavin Sampat, who is faculty at Columbia University. We've been working together a lot on the themes I'll tell you about today. And also a big thanks to the National Science Foundation that has funded much of this work. What brought us into this project and really motivated us to write the piece that we wrote that underlies this presentation I'm giving you is a recognition that early on in the pandemic, that some historical experiences might actually be able to offer us lessons today. And although crisis innovation and crisis innovation policy wasn't really a major part of the innovation policy dialogue prior to COVID, it turns out it actually has a long history. And it's that history that we want to bring into focus and connect to the present as we try to draw lessons for the future. If we take ourselves back to World War II, really the dawn of World War II, in 1940, this is before the US had even entered the war, but while it was beginning to spiral in Europe. In June of 1940, a man named Vannevar Bush, who was a scientist, scientific administrator, he was previously an engineering dean and a vice president at MIT, he actually reaches out to President Roosevelt in the White House, recognizing that the US is likely to be drawn into this conflict, and comes to the White House with a concern that the US military significantly lags the technological frontier of modern warfare. So Bush and a few colleagues of his that were brought into this fold make this case to Roosevelt, who agrees to fund a very nascent, incipient new agency to support federal research to further the national defense. So this new agency, the OSRD, was created in June of 1940 with this one core mission to support R&D and technologies and medical treatments to aid the military in a potential conflict. That said, it also ended up taking on a few other responsibilities, including coordinating research efforts broadly across other agencies and just in general managing the mobilization of US science. And what this turned out to be over the course of the next 5 years of the war was an unprecedented experiment in crisis innovation policy. And really the best reference point we have to draw on today, and we had to draw on coming into the COVID pandemic. But it wasn't only an experiment in crisis innovation policy, it really was the first time the US federal government had a serious hand in funding scientific research. So over the course of the war, this agency entered into over 2,000 contracts with a mix of firms and universities, total value in today's dollars of around $7.5 billion. And I'll tell you in a moment what it led to. But understanding its approach is itself an opportunity to draw modern lessons. So here it's useful to take a step back and think about what's distinctive about a crisis. And here we can actually lean on perspective from contemporaries of the period. One of the leaders of this agency describes it as the need for speed hanging like a sword over the head. Another of them describes the basic problem of mobilizing science during World War II as one of setting up rapidly an organization which would connect the laboratory the pilot plant, the factory, with each other and with the battlefront. And that means not only is it a problem of sourcing research, but it's also one of getting it into production, scaling it up, and then ultimately getting it out to the soldiers and the generals who are going to use it and teaching them how to use it effectively. To support this mission, the OSRD developed a model, and keep in mind, this agency didn't exist. It didn't have any template to follow. This really began from a blank slate, and so this is effectively public entrepreneurship. It took an applied focus. In other words, the focus of its efforts was on technologies that could be put into action quickly, not on developing basic science. It essentially had to take the basic science as given and find ways to put it to good use. It also managed a broad portfolio. So it worked with the military to identify all kinds of pain points and problems that they faced, and then to organize efforts to tackle those problems. And so the effort really was quite broad in its scope. In that sense, it was also coordinated. It engaged top R&D performers in prioritizing speed and quality over, for example, cost. It also was quite attentive to contractor incentives, what it took to get the best firms and researchers to contribute their efforts to the public cause. And this took the form of innovations in patent policy, reimbursements for overhead, and a truly novel contract mechanism that just previously didn't exist. So even contractual innovation. The coordination that took place was not only within its portfolio, and even then not only with the military, but also with other U.S. agencies, federal agencies that were had a hand in supporting research, and even more so with international allies like the British government. And then, as I mentioned before, it had this focus. It had this end-to-end research support model going all the way from the lab bench to the battlefield. And to support this, it invested in manufacturing capacity at risk before solutions had actually been proven to work, and even put its own people into the field. Now, what came out of this are a whole host of innovations that are actually now widely celebrated today. Innovations that not only had immediate impacts on the war's outcome, but were then parlayed into commercial innovations with widespread use. So among these include radar, which, to be honest, is now found in everything from airplanes to autonomous vehicles. That also embedded in it includes microwave communications, which then spawned a whole communications industry. We have high-resolution aerial photography, early computing, jet propulsion. I'm working my way through some of these examples. Pesticides and insect control, including DDT, anti-malarials, penicillin. And then, of course, the most widely remembered one being atomic fission. You're looking at a cyclotron lab at Berkeley in the lower right corner here. But not only did it yield these technological innovations, it also established a precedent, kind of a vision for post-war science policy. So whereas the US government wasn't previously very involved in supporting science and technology after the war, based on this experience, its portfolio dramatically grew in peacetime. And we can talk about that next, because it really tees up our understanding of what took place during COVID, which I'll be going to in just a moment. Now, following the war, Vannevar Bush, the OSRD's director, was asked by Roosevelt to take that experience and provide lessons for what we can learn about the value of science and of funding science in peacetime. Those lessons ultimately led to a dramatic expansion of the federally funded R&D policy system, and it gets spread across numerous agencies, from the Department of Defense to the NIH to the Atomic Energy Commission, which is now part of the Department of Energy. The NSF was among the constellation of agencies involved in funding research, but in the scheme of things, really a puny partner. The NSF is more focused on funding basic science as opposed to applied technology. But amidst all these developments, we also see the rise of U.S. research universities. But importantly, among the agencies that fund fundamental science, the NIH becomes one of the crown jewels of this infrastructure. Its extramural program especially, this is spun out of CMR, which was a subdivision of OSRD. And NIH funds primarily investigator-initiated basic research subject to peer review, and not so much downstream drug development, clinical testing. Really, that's more supported by the private sector. And reflecting that, the NIH funding system is complemented by the rise of a sophisticated pharmaceutical industry, which also has roots in World War II. So a great story that we can use to actually bridge the past to the present is to take a look at Pfizer. Pfizer, we now celebrate as our modern savior, one of the companies that developed an effective COVID vaccine that is helping lift us out of the pandemic. And we all know it as a global $50 billion pharmaceutical industry. But the truth is, it wasn't always in the drug business. Pfizer was founded in 1849 as by two cousins in New York City as a specialty chemical manufacturer. And it remained that way for almost 100 years. In fact, in the early 20th century, one of its main products was citric acid, and one of its main innovations was a method of fermenting citric acid. Now, come World War II, at the dawn of World War II, this is shortly after penicillin had been discovered by Alexander Fleming as a byproduct of the Penicillium notatum mold, the US government is looking for ways to scale up penicillin production. And one of those possibilities is to actually try to ferment this mold at scale. And so the government goes looking for partners, private sector partners that could aid in this effort. And one of the partners it turned to was Pfizer, this chemical company. Pfizer got involved in this effort, which ultimately proved successful. Penicillin was scaled up, and by the end of the war, the effort was producing quantities more than enough to serve the military, enough to begin serving civilian demand, and ultimately save not thousands, but millions of lives. Pfizer then took that experience, learned from it, made a strategic pivot after the war, and began introducing other antibiotics after World War II, and ultimately transitioned into being a pharmaceutical company. And so it just goes to show you how these crisis moments can actually give birth to new firms, new strategies, new industries, and how World War II actually planted the seeds of the firm that 80 years later would rescue us from a new crisis. Which brings me to really COVID itself. A year and a half ago, at the dawn of the COVID pandemic, it was immediately apparent that a number of new innovations were needed. We needed work in a number of different areas. Not only vaccines and COVID therapeutics, but also non-pharmacological treatments. We needed innovation in especially rapid diagnostic testing, contact tracing technology, mitigation technologies, including new ways of conducting business or providing education or other services in a moment when it was very costly to convene in person. We also needed science for policy, evidence to inform decision-making. How does transmission work? What is the appropriate distance for students to be sitting apart in the classroom? Even specific questions like that needed to be answered in a moment when the social costs were enormous, with economies being shut down and cities and countries in quarantine. The global costs were estimated to be on the order of $10 billion of GDP daily. Against those problems, if we go to look at what the US federal government was really involved in supporting, and we go to look at the text that is in the title and abstracts of grants and contracts that it funded, and we make a word cloud out of them, what we basically see is vaccine, vaccine, and vaccine. You see vaccine, protein, doses, mRNA, and so this really is a story of a vaccine development response. To their credit, however, the US government got on this project quickly. So only 3 weeks after the first US COVID diagnosis and only 3 days after the first US COVID death, Peter Navarro in the White House wrote a memo proposing a Manhattan Project for vaccines. This ultimately develops into Operation Warp Speed. And in this case, most of the funding is funneled not through the NIH, but through BARDA, a younger agency. But again, the focus really is on vaccines and a bit on therapies. And in the context of that, also in supply chain management, logistics, getting the vaccines developed and deployed into use. And they took a portfolio approach, funding multiple candidates, not really knowing in advance which ones would ultimately prove to be successful, get through enough trials to receive emergency authorization. This effort bore a number of similarities to World War II. For example, the prioritization of speed over cost, the applied focus, the parallel approach, the strategy to invest in multiple candidate solutions until one was shown to work, and the investment in manufacturing capacity at risk before any of them was actually known to be effective. It also relied heavily on new or new-ish agencies in implementation, like BARDA. Very importantly, it drew on a pre-crisis stock of basic knowledge in World War II, those being early advances in radar and microwave communications in the 1930s, or the discovery of penicillin in the late 1920s. Today, that being, for example, basic advances that had been made in messenger RNA over the preceding 20 years, but also the capabilities of universities and firms. And it also faced some similar trade-offs in patent policy, in managing disruptions to the innovation system. So with all of that said, there are some major differences that I also want to bring into focus. The first of those being that the warp speed effort during the COVID pandemic was explicitly America first. There was limited coordination with international researchers, with, for example, Chinese and Russian vaccine development efforts, which stands in contrast to the way that the US harnessed its partnership with the British government to share information and make progress together. Moreover, beyond vaccines, there was limited government coordination of COVID research broadly. And so I listed out all those problems that needed attention early on in the pandemic, but there was no particular agency keeping track of what those problems were, who was working on them, ensuring that all the holes in the portfolio got filled, avoiding collisions and duplication of effort, allocating scarce resources like sick patients to clinical trials. Instead, what we had is a broad decentralized pivoting by firms and academics worldwide. This might, in fact, reflect the nature of the problem, where in World War II, there was actually one major customer informing priorities, and that was the military. Whereas today, we've had really people and organizations around the world who were in need of innovation. But reflecting all of this, one of the points that really stands out to me, and that we've tried to make bring attention to with different audiences, is how valuable a single coordinating organization or agency running air traffic control on these problems can be. Now, we write about some policy trade-offs, and I will leave these. You can find this paper online on my website, on the Fuqua website. If you're interested, I will leave you and point you in that direction to go read more about them. But some specific policy trade-offs to consider in future crises. Instead, with the last bit of time we have here, what I would like to talk about is what some of the longer-run impacts of crisis innovation can be. Now, if we look back historically and we think about what effects did World War II have on the post-war economy and innovation system, at least anecdotally, according to contemporaries, it opened up entire new fields of research. Contemporaries write, the shift in emphasis and even in direction was enormous. Subjects that were of minor importance prior to the war became of controlling importance in the war, and some were actually born of the war. Now, Bhavin, my co-author in this broader portfolio of papers that we're working on, and I have begun to unpack these questions. So first of all, I can tell you definitively, World War II had a long-lasting impact on the direction of US innovation and where it was located, with really the spawning of technology hubs around the country, including ones you would recognize today, like Silicon Valley or the Boston Route 128 cluster. We're also looking at similar questions in biomedical research and life sciences, anticipating similar effects. And we can begin to think about how the COVID pandemic might have similar consequences. It also led to a deepening of R&D capabilities in firms and universities involved in the effort, as in the Pfizer story that I just told you. And it also laid the foundations for peacetime science and technology policy, especially during the Cold War. As we think about the future in a post-COVID world, what can this teach us? The first lesson we can take away from examining both of these crises and the crisis response side by side are lessons for crisis R&D management, in particular lessons for next time, as I already started to talk through. Another one of the lessons that really merits some focus here is just how important the existing stock of basic knowledge and scientific capabilities will be in a crisis. Those are the resource you draw on in a moment of need. Those exist in firms, academic institutions, trained scientists. These are the assets that we ought to be investing in non-crisis times in order to be prepared for when crises unexpectedly arrive. Moreover, new technological opportunities can follow a crisis. Currently, for example, there's significant enthusiasm around mRNA vaccine development approaches and all kinds of speculation on what kinds of diseases might be able to be tackled, and not just infectious diseases, but other diseases too, with mRNA technology. There have also been changes in collaboration practices, dissemination practices, open access to academic research. And following all of this, especially with this hands-on experience over the past year and a half, some potential changes to innovation policy on the horizon, including more attention and funding for applied use-driven research and consideration of investments in institutional flexibility, supporting the ability to pivot to new problems like those that emerge in a crisis. In fact, there is significant, let's say, energy right now in the US Congress and debate going with it on expanding the US federal innovation research funding system that's partly taking into account, let's say, global technological threats, but also taking into account the experience and lessons we can draw from this most recent crisis and what we ought to be investing in going forward to prepare for it next time. So I'm going to tie things off there. I am happy to take questions if you have any, but I hope this has been interesting. And I wish you all a great rest of your day. So I'll sit around for a few moments. If any questions come in, I will take them. Otherwise, we will wrap up. What I will add in this case is that you should feel free to email me if you would like to follow up. We've done all kinds of connections with the public, with the media. Happy to talk with you more about this or point you in the direction of some reporting on this work and some of the lessons that we can take away from it. But if there are no questions, I just want to thank you all for joining us. And please take note that our next LinkedIn Live session will be on October 6th, Wednesday, October 6th. You can check Fuqua's website for the schedule of upcoming speakers, and you can also follow Fuqua on LinkedIn to be alerted to these and other events. Thank you again. Have a great afternoon, and we'll see you next time.